morning, everyone, again. So, before we start, let's check where are you coming from. I already put a star. This is Sandra and I are from Lisbon, Portugal. This is a picture that Sandra took from the top of our building, and we can see the river Tagus far away. So use the star button. Some of you are already using it in the drawing toolbar. So put the stars from some eastern part of Europe. I've heard that some of you were in Barcelona. Am I wrong? Okay. 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 Can you put a star in Barcelona? No. Okay, no problem. Okay, let's continue for weather briefing for today. So, 6 UTC air mass RGB and mean sea level pressure contours from ECMWF. We have an extensive reach over Azores Island and goes through South and Central Europe. We have intense high over this region of the Balkans. In further north, we have deep troughs across North Atlantic and North Europe, and resulting in, you can see here, resulting in persisting westerlies that are going to continue also in the next days. In this area, in the Atlantic, very well strong flow behind this cold front over here, and some high waves are going to we are going to have some high waves over this area for the next days, because next days we will have some other troughs that are going to move again in this region. So some high waves and persisting high waves in this area of the Atlantic, and they are reaching the coast of Ireland. So this extended frontal bands moving towards northeast and through Scandinavia, and this very well seen cold air cloudiness with some instability in this area. And maybe today over UK and British Isles we can have some storms, a very low probability, but we can have some thunderstorms over here. We have in this region here, we have some short waves embedded in this long wave over the Atlantic. Over Europe, with this high pressure system, we have a stable and dry air mass that is dominating this area. Another interesting features we have here, we have some low pressure system that is over Turkey and moving through the Mediterranean, and also over Morocco we have a low pressure system here with some activity. We had some activity during this past night with lightning activity over this area. Some tips about the air mass RGB. I'm sure that you already know about this, but you know, the cold air mass are the bluish and purple colors. So cold air mass with low tropopause. We have also the reddish colors, very important, the reddish color, because it's stratospheric air, so it's dry, descending, and we have some areas in the eastern part of Europe with dry descending air. It's related to high potential vorticity. So these reddish colors, this stratospheric air acts like a tracer to identify PV anomalies. That's it's very important to monitor these areas. So we have problems with cyclogenesis or rapid cyclogenesis or convection. And the greenish, of course, and the greenish color, very important also. Over here, it's the warm air mass. Don't forget that the green beam is the difference between the 9.7 and the 10.8. So when the surface temperature in the winter is low, the brightness temperature is around 0, and you have more green. It's the opposite in the summer, for instance. We have the surface temperature is high, and the brightness temperature between the 9.7 and 10.8, which is the green beam, it's below 0, so we have less green. Okay, moving on. So next, this image, we have the 10.8 and the equivalent potential temperature. And it's easy to see that the warm air being advected over the Atlantic towards the northern Europe. So some positive values of temperature this morning in this area. So we have here some warm air over Scandinavia. The gradient zones, we have some gradient zones over here. They help us finding the frontal systems at the surface. So we have several gradient zones in this area over here in the Atlantic. Some over this region over the northwestern Europe, and the warm front shield over Scandinavia, and so the cold front. We have area of cold front in cold advection, and also this cold front, and some waves over here. So we have some cold fronts and warm fronts in this area over the Atlantic north of Azores. We also have this cold advection in the eastern part of the Europe, and we can see here this gradient. So we have some kind of a frontal boundary in this region over here in the Mediterranean, and some tongue of moisture air mass over here. Okay, just to show you this cold front with this vertical cross-section. So the vertical cross-section is more or less in this area over here, and the black lines are the isotropes, and we have here also the temperature advection. So these closed lines over here is very stable air, because the vertical spacing between isotropes is a measure of dry static stability. So this high gradient here, it's very stable air, and is a front. In this case, is a backward inclined front, so it's a cold front. And this backward inclined zone extends through the whole troposphere. So we have here in this region over this area here, north of Azores. We have a cold front very well defined with these isentrops. Okay, moving on. So we have the night microphysics just to show you the interesting information about this low stratus and fog in the Central Europe, mainly France and Germany. Of course, maybe other areas, but then we have some high-level cloudiness over this region. So we have the strong contribution of the red color beam in the night microphysics. So this brightness temperature difference in the red color beam is positive. We have a strong contribution of blue in this area, and so we have strong red and strong blue, and the green color. So the green color beam depends on the thickness of this cloud layer. So you can see here it's not very it's thinner, the cloud layer here. So there's a small contribution of green, and over over continents, which have the influence of the surface temperature, this turns almost red in over continents. So the influence of the green beam depends on the thickness of the cloud layer. So some observations around 6 UTC. We can have here. You can see here some fog and freezing fog also, some below freezing temperatures over Germany. So, checking the water vapor image, it's important to know about the upper air dynamics and also to check model performance. So, we have here some nice, interesting features. We have this one south and this one also. So this low pressure system, upper lows that are affecting mainly Turkey and this area of the Eastern Mediterranean, and of course over Morocco. Also, you remember the RGB, air mass RGB with the reddish colors about the dry intrusion. So we have this height of potential vorticity equals 1.5 units, and it's very low tropopause here with the dry stratospheric intrusion over here. Some areas important here over this zone with the jet stream in this area also. And finally, the jet stream, you can see it perfectly with the jet streak over here and some areas of jet streak over upper north. And of course, this is area that we must monitor because we have the front. We can have here a front intensification by jet crossing over here. So it's important to monitor this area over here. And of course, we have some fibers and from this jet cloudiness all over the Atlantic, we have some turbulence over here, so it's important for airplanes. So finally, just before passing to Sandra, from the warning perspective, well, not very busy day for Europe. Anyway, several warnings related to wind, low temperature, snow and ice, some coastal danger. We can see here Ireland, over also here Northern Europe, and over here we have some coastal warnings, and of course some over this area here some avalanches warning. So this rain over Norway, you can see this this precipitation is focused on the mountain ranges. So due to the frontal systems that they are approaching to Scandinavia. So now I'm going to pass to Sandra. She's going to present some weather features that happened last weeks. So Sandra, go on.
So hello everyone. So I'll be presenting some overview of cloud features in RGB images. A showcase for January. We can see in this RGB air mass image at 0 UTC. Some things Angela has already explained it, but I'll say it again. So why is important to use this air mass image? So we can identify some regions of dry intrusion, and to analyze the cyclogenesis processes. Over here, east of Iceland, we can see a cyclogenesis area. We can see also some jet fibers associated with the jet stream. In greenish colors, we can see also the influence of warmer air in the Azores. Still some dry intrusion from the north of from British Islands and to Iberian Peninsula. We can see here also that Central Europe has some depressionary systems, a little more difficult to analyze in Eastern Europe due to the evolution of different frontal systems. Another showcase now with the natural color images. This case was you can see it also in the EUMeTrain web page. So it was an event of dust. You can see it here. So this event started with westerly winds flowing from Algeria and going all the way to the Black Sea. So in this image, the light blue colors identify the cloud features and some snow, and the whitish colors you can identify some lower clouds. Also, this dust plume that you can see over the Mediterranean is best visible due to the contrast with the water surfaces. Still, to this case, I have plotted the weather synopsis. So you can see here in Algeria some dust or sand driven by wind. Near Greece, still some widespread dust. So I think it was very interesting to see these observations. Still a good image to detect dust is the RGB dust, and we can see here in magenta the colors that identify the plume. So why is magenta the color that identifies the plumes? So the difference, the brightness difference used in the red channel is positive, so we have a great contribution on the red color, the magenta. This RGB can also help us with another type of clouds, some seen ice clouds. You can see it here in this darker area. Also ash and low level humidity. Another situation in the beginning of these months was an interesting situation, because all of Europe was having very different depressionary systems, and they were persistent for several days. We can see here the anticyclonic ridge extending to north of Europe. So this situation was very interesting, because this low system centered in the Gulf of Biscay will give some significant weather in the next days. So it is, you can see now this occlusion system going through Spain and France, and then it will merge with the another low system, giving some snow over Italy. Still for the next days, you could see some snow on the ground here in the Cantabric Mountains over Spain, and the Pyrenees over France and Italy. So we had some luck with these images, because you don't have other cloudiness, so we can see this is snow. Still here an image from our highest mountain, only 2,000 meters. Still for snow identification, you have some other interesting products like snow RGB and microphysics day. So I hope you can have some time and consult the MCG interpretation guide on the internet. I'll pass to Angela.
Thank you, Sandra. Very well, like a wrap-up of some of the events for the last month. So let's continue with snow. These past weeks there have been some nice examples of this sea lake effect snow over Southeast Europe. We have some examples in the Adriatic and in the Black Sea. 2 days ago there was a big event over the southern parts of the Black Sea coastline. So just some words about this lake effect snow. It's the principle, the main principle is quite simple, but we have some little difficulties when we have some differences with the direction of wind, speed of wind, and the temperature gradient. But the main principle is quite simple. So it forms when cold wind air masses move over warm water. So we have the water here, and we have the cold air mass moving over warm lake waters. Well, the lake moisture evaporates into the cold air. Of course, we have warm air is lighter and less dense than cold air, so it rises, begins to cool, and then we have the clouds and, of course, the precipitation. In this case, it's very cold, and we have snow. We have here in this downwind coastline, we have convergence due to increased friction in this area, less friction over water, more friction over continent. And if we have some topographic features, we have some enhanced precipitation, so enhanced activity, we can have here orographic lifting. Another important is the lake fetch. Some tips. So the lake fetch is this. It's the area the wind must go through the water. So we have some tips about this lake fetch. Under 30 kilometers, we have little or no snow. If it is around 100 kilometers or over, we can have heavy snow over here. The wind direction is important, and it's also important not to have directional shear in the lower layers until 700 hectopascal. It's important. So another important thing is the temperature gradient between the cold air and the warm water. Some tip, of course, this difference must be over 13 degrees. So it, of course, occurs only downwind side of the lake or sea. The snow clouds most often form in narrow bands, where the size and the orientation of these bands are determined by the shape of the lake and the prevailing wind direction. So here again, the fetch is important. So any large body of water can generate lake effect snow downwind if it remains free of ice, of course. So we have to have this temperature gradient. Okay, 2 days ago or 3 days ago, we have this lake effect snow. In this case, it's Black Sea effect snow. Black Sea is over this area here, and this star here is Istanbul. And we have on the 16th, 12 UTC, this boundary of cloudiness. So clear skies over here, cloudiness over here, dense cloudiness over here. So the cold air was already advecting, and it's nice to see that we have some cloud street formation over the Black Sea, and of course the clouds lines with the wind direction. So when we have cloud streets, we have a strong clue of the prevailing wind direction. So we have here northerly winds. On the right side here, we can see some cumulus cloudiness over the Black Sea. So activity is reaching somehow Turkey, all over Turkey. So we had some snow all over Turkey, and some places heavy snow in some places of Turkey, and even in places further south. So we have temperature around the sea surface temperature around 5 to 10 degrees, and in the upper air, so at let's say 850 hectopascal, we have minus 15, and it was colder in the upper levels. So we had a long fetch, all Black Sea, so all Black Sea. So we have here a long fetch, and of course we have also the wind direction was all north, from north, and all from so we have the wind blowing over the whole area of the sea. So there was also some thunder, some lightning activity, mainly over this region and also over this coastline over here. So some observations, not very well, but you can see it's like a star. These dots here, and this is snow. We also have some snow showers over this here, mainly snow. It's so heavy snow, and thunderstorms near Cyprus. So some activity during the 17th of February. Some pictures that we have here from Istanbul. So this is the evolution of the snow bands over the over Istanbul area, and some nice picture also in approaching the bridge in Istanbul. These snow bands approaching. Okay, that's everything for today. I want to thank you for joining and talking about snow again. 2 days ago, EUMeTrain published a new module about the climatology of snow cover and snow water equivalence. So this module talks about the snow water equivalent, how it is determined by satellite instruments, and of course how it can be used and can be applied for regional climate studies. So see because it's interesting. So next weather briefing will be on 19 March and by even. And so I thank you again for joining us.